Today we shall study about Boltzman constant. See, Boltzman constant is represented by Kb and its value is 1.38 into 10 raised to the power minus 23 joules per Kelvin. Now, it tells us energy is directly proportional to temperature. It relates the relation between energy and temperature of a system. Then it is kBT. Energy of the system is kBT, where kB is the constant of proportionality. See, here we can say that the molecules are moving in all the three directions. This is x-axis, this is y, this is z. So molecules are moving in this direction, 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 and degree of freedom of movement of molecules along x-axis it is 2, along y-axis it is 2, this and this, positive I and negative I, and along z-axis it is 2. So average energy along one axis it is kBT divided by 2. And if there are three axes, then we can say that total energy is equal to 3 kBT by 2. But this is for one molecule, and for n number of molecules it will be E is equal to 3 n kBT divided by 2. Here kB is the Boltzmann constant and its value is equal to 1.38 into 10 raised to the power minus 23 joules per Kelvin. Now we shall do one more topic, and that is derivation of ideal gas equation on the basis of kinetic theory of gases. How can we drive it? This is very interesting topic, and we can see that the molecules in a gas, if this is the container is here, it is L. Length of one edge of the container is L, and this is a cubic container, and number of molecules in this of a monoatomic gas is contained in this container with a length of an edge is L. Suppose here it is one molecule that is moving towards x-axis and its velocity is ux. So now we say that F is equal to, what is force? Force is rate of change of momentum. Rate of change of momentum. Or F is equal to delta P by delta T. What is the change in momentum? See, if it strikes with the wall, the molecule strikes with the wall, then with the velocity ux, and as the collision is elastic, then after collision the velocity of the molecule will be minus ux. Then change in momentum will be mux minus mux. That will be 2mux. And then force is equal to, see, force is equal to delta P by delta T. It is equal to 2mux divided by delta T. And see, delta T is equal to d by s, distance travelled between two collisions, and s is the speed. So distance travelled between two collisions is L, this L, and again this L. So it will be, distance travelled will be 2L. So distance travelled is 2L and speed of the molecule is taken as ux. Then we replace delta T by this value. What we get? Let us see. F is equal to 2mux divided by 2L and into ux. This becomes, 2 cancels out with 2. This becomes mux square divided by L. So this is the force. Now pressure. What is pressure? P is equal to pressure. This is force per unit area, and area of the edge is F by L square. Okay, now we see what happens. P is equal to, force is equal to mux square divided by L, and divided by L square, divided by L square. This becomes mux square divided by L cube, and L cube, length into length into length, it becomes volume. It is volume. So we get PV is equal to mux square. Now let us see what happens next. We have taken the velocity of one molecule along one axis, only x-axis. So we have to calculate the root mean square velocity c square, which is equal to ux square plus uy square plus uz square. The square of the velocities in all the three directions, when taken, then that will be when some of these velocities are taken along all the axes, then we get the root mean square velocity. Then by convention we know ux is equal to uy is equal to uz. All the three velocities are equal. Then we can write it as ux square plus ux square plus ux square. All the three are equal. This is equal to 3ux square. And when it is 1 by 3 c square is equal to ux square. So we take this value of ux square and replace this value in this equation. PV is equal to mux square. PV is equal to mux square, which can be written as 1 by 3 mc square. Now, you know, if we multiplied it both sides by 2, by 1 by 2, then what we get, it is 3 PV by 2, it is equal to 1 by 2 mc square, and this is the kinetic energy. C is the velocity, this is the formula for kinetic energy. And by Boltzman we know that E is equal to 3 by 2 nkbt, and here potential energy is 0 because there is we have assumed that there is no force of attraction or repulsion between the molecules. Hence, in ideal gas potential energy is 0, and this whole internal energy is only due to kinetic energy, and that is equal to 3 by 2 nkbt, which we have studied, and this is equal to this. So we can say that 3 PV by 2 is equal to 3 by 2 nkbt. 3 by 2 cancels out. PV is equal to nkbt, and nkb here is equal to R, which we have studied, and it becomes R is equal to nkb. Here R is equal to kb and A, and if we divide this equation, see, if we divide this equation by Na, kb and A Avogadro number, then it will become equal to nR, and then it becomes PV is equal to nRT. Okay, then we get the equation PV is equal to nRT, and this is the ideal gas equation. Here PV is equal to, this is total number of molecules, and total number of molecules is equal to number of moles into Avogadro number. Now we replace it with PV is equal to NA KB T, and here KBNA is equal to R. Hence we get the equation PV is equal to nRT, and this is ideal gas equation. So we have derived this ideal gas equation on the basis of kinetic theory. Thank you for watching the video.